Welcome to the Deep Dive. Today we're tackling something pretty central to Ethereum's future. Rollups. Specifically, the different stages they go through.
Right. If you think of Ethereum, maybe like a busy main highway.
Yeah, always jammed during rush hour.
Exactly. Rollups are kind of like building these super fast express lanes right next to it. They handle a lot of the transactions much quicker, much cheaper.
And then they report back to the main highway, basically.
That's the idea. They periodically submit a summary, a proof, back to Ethereum.
Okay. And for you developers listening in, maybe you're already building on layer 2 or thinking about it.
Yeah.
Our goal today is really to unpack these roll-up stages.
Yeah, we want to give you a solid handle on what these stages mean, stage 0, stage 1, stage 2, why they matter, what they signal about a project's maturity, its decentralization.
And ultimately, how that affects you when you're choosing where to build.
Exactly. It impacts the guarantees you get, the risks you might be taking on.
And we've been digging into some good material for this. There's the Rollup Comparison Framework paper on ARX4, a pretty clear guide on Binance Square called Demystifying Rollup Stages.
And also some interesting discussion threads like Polinia's piece on minimum viable decentralization, stage 1 specifically.
Yeah.
Even looked at some Splunk docs on data rollups, just for that broader aggregation concept.
Right. So the plan is start high level, fundamentals, why stages, then get into the weeds of each stage 0, 1, 2.
And then zoom back out a bit, place it all in the context of the wider Ethereum ecosystem, talk proof systems, modularity, things developers really need to grasp.
Okay, sounds like a plan. So fundamentals first. For a developer who gets blockchain basics, how do we define a rollup technically?
Well, fundamentally, a rollup is its own blockchain, right? But it's anchored to another one, usually Ethereum, through smart contracts.
The anchor is key.
It's absolutely key. The rollup executes transactions on its own network much faster, potentially cheaper. But then, periodically, it takes a batch of these transactions, compresses the data, and publishes it onto Ethereum.
Along with some kind of proof or commitment.
Exactly, along with a state root, basically a cryptographic fingerprint of the rollup's current state. Those smart contracts on Ethereum verify things, enforce rules.
So it inherits Ethereum security, but handles execution elsewhere.
That's the core value proposition. You get scalability without completely sacrificing the security guarantees of the main chain.
And this ties into finality, right? When can a user or an app be really sure a transaction is settled?
Right, that's a crucial point. A transaction might seem confirmed quickly on the rollup itself, but true, L1's secured finality happens only when the rollup state, reflecting that transaction, is successfully processed and accepted by the anchoring smart contracts on Ethereum.
According to the rules of that specific rollup's contract.
Precisely. And those rules differ. Optimistic rollups, for example, have this challenge period. The state is assumed correct unless someone proves otherwise within a certain window.
Innocent until proven guilty, kind of?
Sort of, yeah. Whereas ZK rollups use these validity proofs, cryptographic proofs that guarantee correctness upfront. We'll dig into that more.
Okay. But the point is, finality depends on that L1 interaction. And while the basic model is similar, rollups compete. They have different features, different ways of doing things.
Exactly, and that's where the stages come in. They're a framework, really, to help classify and compare how mature, how decentralized these different rollup projects actually are.
So it helps developers and users, too, understand the guarantees, maybe the risks associated with a specific rollup. It's not just about speed and fees.
Absolutely. Understanding the stage tells you a lot about the underlying trust assumptions. Are you relying more on the core team or more on the code and the mathematics? A later stage generally means stronger guarantees, less reliance on a small group of operators.
Makes sense. So it's about assessing the robustness of the infrastructure you're building on.
Couldn't have said it better myself. It's about looking under the hood.
Okay, let's start at the beginning then. Stage 0. The full training wheels stage, what does that look like?
Stage 0 is, well, it's basically the initial phase. The rollup is running. Transactions are likely being posted to L1, so the data's there.
So you could theoretically reconstruct the state from on-chain data?
Theoretically, yes. The source code might even be available, but the key thing is the actual operation is highly centralized. The operators, the core team, usually have significant control.
Like they can upgrade the system pretty easily, maybe censor transactions if they wanted to.
Potentially, yes. They often control the sequencer, the component that orders transactions, and the process for submitting state updates to L1. There might not be a fully permissionless way for others to challenge or propose state updates yet.
Some of the sources mentioned Optimism and Starknet having been in this stage, at least initially. I remember reading Optimism didn't launch with fault proofs, fully enabled for everyone, for instance.
Right, exactly. Features like fully working, permissionless fraud, or validity-proof systems might still be under development or restricted. The Fellowship of Ethereum Magicians discussion kind of framed stage 0 as under construction.
Which implies, proceed with caution, the guarantees are weaker.
You're placing more trust in the operator's competence and good intentions. It's not bad, it's just early. The system relies heavily on that central entity for its immediate security and operation.
Okay. So what's the first major step away from that centralization? Taking off some of those training wheels.
That brings us to stage 1, limited training wheels. This is a really significant transition.
How so? What changes?
The big shift is towards leveraging the smart contracts on Ethereum much more for actual governance and security enforcement, reducing that direct reliance on the operators. A key feature you often see introduced in stage 1 is something called a security council.
Right, I saw that mentioned. It sounds like a sort of emergency brake.
That's a good way to put it. It's typically a multi-signature group composed of, trusted individuals or entities in the ecosystem. Their main power is usually the ability to intervene in emergencies.
Like if a critical bug is found, they could pause the bridge or the state updates.
Exactly, to prevent funds being stolen or the system state getting corrupted while a fix is worked out. But as that Polinia article points out, even with maybe 8 or 11 members needing a supermajority, like 76%, to act,
It's still a form of centralized control, just distributed a bit more.
it absolutely is. It's a pragmatic step, a safety net, but it's not full decentralization yet. It's limited training wheels.
So besides the Security Council, what else technically defines stage 1? What needs to be in place?
Several things. Critically, you need a functional proof system running. For optimistic rollups, this means the fraud-proof mechanism needs to be operational and, ideally, permissionless for submission.
Meaning anyone can submit a fraud proof if they spot an issue, not just whitelisted actors.
That's the goal, yes. It empowers the community to act as watchdogs. And crucially, there must be mechanisms for users to exit the system, to withdraw their funds back to L1, even if the main operators go offline or if the Security Council pauses the system. Users shouldn't be trapped.
That user exit guarantee seems vital. We saw Arbitrum hit this stage, though their fault proofs were initially behind a whitelist, according to one discussion.
Right. And more recently, Base made the move to stage 1. The reports mentioned they implemented fault proofs and set up their Security Council, explicitly aiming for more decentralized governance, less direct Coinbase control.
So it's about distributing power and having verifiable checks and balances in place via the L1 contracts.
Precisely. Governance also matures. Regular upgrades shouldn't just happen overnight. They should go through a proper governance process with significant delays that Polinia piece suggested over 7 days for optimistic rollups.
Gives people time to check the code, raise objections, or even exit if they don't like the upgrade.
Exactly. Emergency upgrades after a pause maybe might have shorter delays, but still need that strong Security Council consensus.
Polinia also mentioned an interesting idea for those emergency upgrades, like different time locks depending on the council vote. 100% approval means a super short delay, but maybe 76% means a longer one.
Yeah, exploring ways to balance speed in a crisis with caution. It shows there's still experimentation happening within stage 1 itself, maybe even involving broader L2 governance or L1 social consensus as a last resort.
Okay, so stage 1 is a big step up in decentralization and security guarantees, but still has that safety net, those limited training wheels. What about taking them off entirely, stage 2?
Stage 2, no training wheels, is really the ideal state, the end goal many projects are aiming for.
Fully decentralized.
As much as possible, yes. The idea is that the entire system upgrades, state validation, everything is managed purely by the smart contracts on Ethereum. There's no need for a Security Council with special override powers.
So no privileged actors.
Exactly. The permissionless proof system, fraud proofs for optimistic, validity proofs for ZK, is the core security mechanism enforced by the L1 contracts. And a key principle is that users must always have sufficient time to exit the system if an upgrade they disagree with is proposed and passes governance.
Protecting user sovereignty.
Absolutely. The Demystifying Rollup Stages article mentioned projects like Fuel and Degate aiming for this. It aligns with Vitalik Buterin's vision, mentioned in those fellowship discussions, of rollups being fully secured by Ethereum. The L1 contracts are the ultimate arbiter.
Okay, that makes the progression clear. Now, we've mentioned fraud proofs and validity proofs a few times. Can we dig into the mechanics a bit more? How do they actually provide finality? Let's start with optimistic rollups.
Sure. So optimistic rollups, as we said, work on that innocent until proven guilty idea. A sequencer proposes a new state root, claiming it's the correct result of processing a batch of transactions.
And they have to put some money down.
Yes, crucially, they have to post a bond stake, some cryptocurrency on layer one. This bond is at risk. There's then a challenge period, could be days, maybe a week or more.
Right.
During this time, anyone monitoring the rollup can check the sequencer's work. If someone finds evidence of a fraudulent state transition, like a calculation error or an invalid transaction included, they can submit a fraud proof to the L1 smart contract.
And the proof has to demonstrate the error.
Exactly. It needs to pinpoint the invalid step. If the L1 contract verifies the fraud proofs, the incorrect state update is rejected, and the sequencer who proposed it typically gets their bond slashed.
Ouch. So there's a strong economic incentive, to be honest.
Very strong. The potential penalty for cheating outweighs the potential reward. If the challenge period passes without a successful fraud proof, the state update is considered final on L1.
So finality relies on this economic game theory and the window for challenges. What about ZK rollups? They sound quite different.
They are a whole different ballgame, technologically speaking. ZK, or zero-knowledge rollups, use advanced cryptography. Instead of assuming validity and waiting for challenges, they proactively prove validity.
Oh.
When a batch of transactions is processed off-chain, the ZK rollup system also generates a cryptographic proof, often a snark or a stark. This proof mathematically attests to the fact that all the computations were performed correctly according to the rules, leading to the proposed new state root.
Without revealing the actual transaction data itself. That's the zero-knowledge part.
Precisely. The proof confirms the integrity of the computation without leaking private details. And the amazing thing is, these proofs, while potentially intensive to generate off-chain,
Are relatively cheap and fast to verify on-chain.
exactly. Verifying the proof on the Ethereum smart contract is computationally much easier than re-executing all the transactions. So once that validity proof is submitted and verified on L1,
Boom. It's final.
Right.
No challenge period needed.
correct, the mathematical proof is the guarantee. Finality on L1 can often happen much faster, maybe within minutes or hours, basically the time it takes to generate the proof batch and get it included and verified in an L1 block.
That's a significant difference in finality time compared to optimistic rollups. Huge implications for things like withdrawals or interacting between L2 and L1.
Absolutely. It affects user experience, capital efficiency, composability. It's one of the core trade-offs developers consider.
Okay, let's shift gears slightly to architecture. We hear terms like monolithic and modular applied to rollups. What's the difference and why should a developer care?
So a monolithic rollup architecture is kind of the classic all-in-one design. You typically have a single sequencer entity, or a small set, responsible for everything, ordering transactions, executing them, calculating the new state, and then posting both the transaction data and the state root or proof to Ethereum.
Tightly integrated.
The one component or one logical system handles the whole pipeline.
And modularity is about breaking that apart.
Exactly. Modularity is a trend across blockchain design, and for rollups, it means separating those core functions. Maybe you use one specialized system for sequencing, another for execution, and critically, you might use a different layer for data availability instead of posting all the raw transaction data directly to Ethereum L1.
Like using Celestia or EigenDA or something for data.
Potentially, yes. Or maybe a dedicated data availability committee. The idea is to potentially gain benefits like increased scale by using a cheaper data layer, or maybe different security trade-offs.
How does this impact a developer, though?
Well, it changes the trust assumptions. If data isn't going directly to Ethereum, you need to understand the security model of the alternative data availability layer you're relying on. It also affects things like the cost structure and potentially the complexity of the overall system. You need to know where each piece lives and what guarantees it provides.
That rollup comparison framework paper mentioned validiums in this modular context. They use ZK proofs for execution correctness.
Right, so you get that fast finality for state transitions via the ZK proof on L1.
But they keep the actual transaction data off-chain, maybe with a data availability committee or something.
Yeah.
The paper noted some debate if they're true rollups.
Yeah, the debate centers on that data availability aspect. If the data isn't guaranteed to be available, unlike posting to Ethereum, can users always be sure they could force their exit or reconstruct the state if needed? For a developer, using a validium means accepting that different trust assumption about data availability in exchange for potentially much higher throughput because you're not paying L1 gas for data storage.
Trade-offs again. What about based rollups? That sounds different too.
Base rollups, or sometimes called L1 sequenced rollups, are a fascinating idea. Essentially, they propose getting rid of the rollup's own sequencer entirely.
So who orders the transactions?
The underlying Layer 1 Ethereum block builders would directly include rollup transaction batches within the L1 blocks they construct.
Wow, okay, so the rollups transaction ordering becomes as decentralized and censorship resistant as Ethereum itself?
That's the core appeal. You inherit Ethereum's liveness and decentralization for sequencing directly. It's a very strong guarantee.
What's the catch?
Well, it generally requires changes to the L1 protocol or infrastructure, like relying heavily on proposer-builder separation, PBS, being fully implemented and robust on Ethereum. It shifts the sequencing role onto L1 participants. For
Hmm.
developers, the big plus would be those very strong liveness and censorship resistance properties inherited from L1.
And quickly, enshrined rollups, is that similar?
It could overlap, but enshrined usually implies even deeper integration into the Layer 1 protocol itself. Think of Ethereum becoming natively aware of the rollups state transitions, perhaps even helping verify them directly within the L1 consensus, not just via a smart contract. It might still have its own sequencer, but use L1 verification mechanisms.
So even tighter coupling with L1 for potentially greater efficiency or security, but requires significant L1 protocol evolution.
Exactly. It's further out on the horizon, likely.
Okay, so we have these stages, different proof systems, monolithic versus modular designs. It's a lot to compare. That Arcsov paper, the rollup comparison framework, tried to visualize this, right, using 4 dimensions.
Yeah, it proposed looking at finality time, familiarity, modularity, and maturity.
Can you break those down quickly?
Sure, finality time, we've discussed that, how quickly transactions are L1 secured. Familiarity, largely about EVM compatibility. Is it easy for Ethereum developers to jump in, use Solidity standard tools?
Okay.
Modularity, does it separate components like data availability, or is it monolithic? And maturity, how long has it been running? How battle-tested is the code? How big is the ecosystem?
And the idea is these dimensions influence things developers care about, like composability, user experience, trust assumptions, robustness.
Precisely. The paper used a radar chart to visualize this. Interestingly, they framed the axes so a smaller area was better using unfamiliarity and immaturity instead of familiarity and maturity.
Ah, clever. So you want low unfamiliarity, low immaturity, low finality time.
Exactly. They showed an example comparing StarkNet and Optimism at a point in time. StarkNet might have had faster finality, being ZK, but higher unfamiliarity, not EVM native then. It also showed modularity, being a volition where users could choose data posting. Optimism was monolithic, maybe higher familiarity EVM, but slower finality historically.
So it's a framework for developers to visually map out these trade-offs based on what's important for their specific application.
Exactly. There's no single best roll-up. It depends on your priorities. This framework helps structure that evaluation.
So bringing it all together, understanding these stages, the proof systems, the architectures, it's really about empowering developers, isn't it?
Absolutely. It lets you evaluate the solutions critically, understand the trade-offs you're making, and choose the platform that best aligns with your application's needs and your tolerance for different kinds of risk or centralization.
And this whole progression through the stages towards more modularity, better proofs, it's all driving towards that bigger goal of scaling Ethereum securely and making it accessible for more users and more demanding applications.
That's the end game. Increasing security, increasing decentralization, increasing user trust, all while scaling throughput. These stages are milestones on that journey.
This has been super helpful, really clarifying the landscape. So key takeaways. Roll-up stages mark increasing decentralization and security from stage zero's heavy reliance on operators through stage one's introduction of proof systems and security councils, aiming for stage two's full smart contract governance.
And remember, those crucial differences in proof systems, optimistic versus ZK impacting finality, and the architectural choices between monolithic and modular designs, each carrying different trust assumptions and performance characteristics.
Definitely things for you developers to keep in mind when evaluating where to build next. The stage matters.
It really does. It gives you a crucial signal about the maturity and guarantees of the network.
Okay, that brings us to our final thought. We've talked about these defined stages 0, 1, 2, but this space moves incredibly fast. As rollups mature, maybe borrow features from each other, CK rollups add EVM compatibility, optimistic rollups explore faster finality. How fixed are these stages?
That's a great question. Could the lines blur?
Yeah, could we see hybrid models emerge that don't neatly fit into stage 1 or stage 2 as currently defined? Or might we need entirely new ways to think about and categorize L2 scaling solutions as innovation continues beyond this framework?
It's definitely something to watch. The current stages provide a valuable map, but the territory is constantly changing. What new models might emerge? It's an exciting time to be building.
Indeed it is. Lots to think about. Thanks for joining us on this deep dive.